Hello everyone, welcome back. In this lesson, I would like to talk about the nature of human observations. In the last lesson, we have seen how expert opinions or textbooks may not be reliable sources of information for clinical practices. Can we then trust our own clinical experiences, our own observations? Let's imagine a treatment by which 12 out of 18 patients have recovered. Is this treatment effective? In other words, A is 12 and B is 6 in this table. Let's say this was a treatment for depression. Do you think that this treatment is effective? Please jot down your answer on any sheet of paper by your side. By the way, a small piece of advice here. It will be a greater learning experience if you really jot down your preliminary answer somewhere. No one will check it. Simply, you will have more fun by seeing your thinking 5 minutes ago. Do you think that this treatment is effective? Yes or no? Based on my past experiences of asking the same question, I would bet half of you may have answered yes to this question. However, let us further assume that of the 9 patients who did not receive the treatment, 6 recovered and 3 did not. In other words, C is 6 and D is 3 in this table. Is this treatment effective? No. Regardless of whether you receive the treatment or not, 2/3 of the patients recover. The treatment is apparently not effective. Remember, doctors in principle can only know the 2 cells out of these 4, the fate of those who receive the treatment. That is, therefore, a logically insufficient ground for judging the effectiveness of treatments. We often hear claims similar to the following. Assuming that they are correct, are their implications correct? Most traffic accidents take place within 2 miles from the victim's home. Will it then follow that if you are driving 200 miles away from home, you're safer? Most kidney stone patients drink less than 3 liters of water per day. Does it then follow that if you are drinking more than 3 liters per day, you will be free from kidney stones? In both cases, we are making the same error of inferring the causation based on 2 cells out of the 4. However, to begin with, are the statements based on such clinical and human observations trustworthy? In a very famous experiment by Rosenthal, half the students in psychology were handed bright rats and the other half dull rats, even though these rats had been simply randomly divided into 2 groups. When they ran maze running experiments with these rats, scores of bright rats were much better than those of dull rats. This so happened probably because the students trained the rats better when they thought that they had bright rats, and also because their observations were inflated. Is this only about rats? No. Videotapes of peer interactions of 8-year-olds were shown to teachers to rate their happiness, emotional adaptation, and stress coping. Half the teachers were told that the kids were from broken families, while the other half that they were from families with both parents. Can you guess the results? Well, the ratings by the first group of teachers were lower than those by the second. Is this only about psychological observations? No. Do you know a parallax of a star? If the Earth is revolving around the Sun, the angle at which you look up at a star in the sky should be different between the summer and the winter, right? This is the parallax. In 1669, a famous British natural philosopher, Robert Hooke, observed the parallax and reported it to be approximately 30 seconds. This was the convincing proof for the Copernican theory. However, when Jean Picard, a French astronomer, applied the same method and reported that he observed no parallax, the theory suffered a major setback. Several years later, John Flamsteed, the first astronomer royal of the Royal Greenwich Observatory, reported the parallax to be 40 seconds. Well, do you know how big the true parallax of a star is? It's less than a second. So was Robert Hooke or John Flamsteed closer to the truth, who said the parallax was 30 or 40 seconds, or was Jean Picard closer to the truth, who said it was 0 seconds? So, upon what can we base our clinical decisions? Expert opinions or textbooks may not be reliable sources of information. Neither can we trust our own unsystematic clinical observations. But surely we want to base our clinical decisions, what matters to the patients, upon firm grounds. We call this firm ground evidence. Evidence examines clinically meaningful results, that is, true endpoints, in a valid way, that is, without bias or systematic error, with due consideration for random error. If the central blue circle represents the underlying truth, then every study is an attempt to hit this target. When there is a systematic error, the dart will miss the target in a certain direction. When the random error is big, the dart will miss the target in all directions. But I surely want to base my clinical practices on studies that hit the target.